So, and then what you're thinking about is all of these strategies that we have right now. So now we might be able to use some of them. So this is on page 623. We are doing those two. I'm going to add a third one to it. So part C to this, prove So there's 3 for you to do. So here is our first one. For our first proof, this proof 1 works best if you change things to sine and cos. So cotangent is cos theta over sine theta plus sine theta over cos theta. On this side, you would have 1 over sine theta times 1 over cos theta. So on the right-hand side, after multiplying those out, you have a single fraction in sine and cos. On the left-hand side, you have not a single fraction. We need a common denominator. So this one needs to be multiplied by cos, and this one by sine and sine, which will give us cos squared theta plus sine squared theta. Woo, cos. And cos squared plus sine squared is 1. And we're done. That's probably the most common way to do that one, and that's what I would recommend. Proof number 2. So, in proof number 2, this is a proof where recognizing there's a relationship between cosecant and cotangent, because we know this formula, and I'll put it off to the side here. We know that cotangent squared theta plus 1 equals cosecant squared theta. So if I go back to my strategies, this one is a key one where I want you to think about the fact, when I say on here, always be aware of your goal, be aware of the other side. That's going to help you do this one quicker. Seeing that both sides are cotangent and cosecant squared should give you a clue that you'll want to use that identity. Okay? So when we look at that question, and we see cotangent on this side and cosecant squared on this side, and those are the only functions, this is one where I wouldn't change things to sine and cos. I would first say, hey, maybe I can change everything to cotangent squared. And you can do that because on this side, instead of cosecant squared, I can write cotangent squared plus 1 instead. Now when you multiply and distribute this through, that will give you cotangent cubed theta plus cotangent theta. We still have minus cotangent theta. Of course, those go away. And the left side is equal to the right side. And we're done. So being aware of the other side can sometimes give you a hint as a way to do it faster. Okay? How many people were trying the sine and cosine? Okay, do you want to see what that looks like? Okay. So this is shorter. But had you not seen this, and you went sine cubed theta, oops, cos cubed theta over sine cubed theta, and cos theta over sine theta times 1 over sine squared theta minus cos theta over sine theta. So this is how you would start. The left-hand side is already a single fraction. The right-hand side you have cos theta over sine cubed minus cos theta over sine theta. This isn't a single fraction. You would need to get a common denominator, so you'd multiply the top here by sine squared and sine squared, and you would get cos theta minus cos theta sine squared theta over sine cubed theta. So at this point, we have our denominators the same on both sides, but the numerators are different. This one has cos cubed, this one has cos and sine squared. So if I want to get my numerators the same, and I'm looking at both sides, I would like them to be all in cosine. Is there a way that I could change the sine squared so it's in cosine? Yes, because sine is equal to 1 minus cos squared. And if you do this and now distribute the negative cos, you will get cos minus cos and then plus cos cubed and we're done. So a little bit longer, changing to sine and cos, but it still works. And the interesting thing is you still need to use the strategy of using one of our Pythagorean identities to solve it. So had we saw that strategy earlier, it would have made our life a lot easier. But not wrong. And the third one that I added, I put this one in here so that you would recognize or begin to think of the following strategy, which is recognizing difference of squares. If you see a difference of squares, sometimes it's going to be very helpful to factor. So this one in particular would not be fun to do because of the powers of 4. But if you notice that the left-hand side is something squared minus something squared, you can factor it. And it can factor to tan squared and tan squared, secant squared and secant squared. One will be positive, one will be negative. And then to think about, there's a relationship between tan squared and secant squared. I'll write it up here in this red box. We know that tan squared theta plus 1 equals secant squared theta. Can you rearrange that to match one of those two factors? This one right here, right? Can you see that if you minus the secant squared, then it would, and you move the 1 over to the right-hand side, then that second part is equal to negative 1. Then if we distribute, all done. Okay, practice ones. More proofs. 3, 5, 6, I, 7, I, and 9I.
So yesterday's homework was supposed to be on page 612 because some of those things, questions that have already been assigned by the CPE.
Oh, were they?